In chapter 9, lesson number 6, area of composite figures. A composite figure is a figure made of two or more two-dimensional figures. Two or more two-dimensional figures. Like the composite figure shown to the right here is made up of two rectangles. Rectangle to the right and rectangle to the left. Draw a composite figure made of a rectangle and a right triangle on the graph paper below. Let me show you how. This is a composite figure of a rectangle and a right triangle, so that if you take a line this way, it will appear that really we have here rectangle to the left and right triangle to the right. The dimensions of the city pool are shown. What two-dimensional figures are used to make the shape of the pool? It's clear that it's a rectangle and a trapezoid. This is a trapezoid. Let me show you. This is the rectangle. And this part to the right of the rectangle is a trapezoid. So the pool is a rectangle with a trapezoid at the entrance. Now, how can we find the area? How could you determine the area of the pool floor? Very easy. Just evaluate the area of the rectangle, then evaluate the area of the trapezoid, then you add them, separate the shape into a rectangle and a trapezoid, find the area of each, and add to find the total area. We must add. Let's take examples to make everything clear. Example 1. Find the area of the figure at the right. The figure at the right can be split out into a rectangle and a triangle from this side. If we do this, so it becomes now a rectangle and a triangle. In this rectangle, as you can see, dimensions are 6 and 10 here. So 6 multiplied by 10, and this will give you 60. And for the triangle, it needs base and height. The height is clear as 4, so we need to find out what is the base. Of course, we all know that in the rectangle, this side, all of it is exactly the same as this one. So if this one is 10, this one is 10 as well. And a part of it is 6. This is 6. So the remaining part will be 4. So mentally, 10 minus 6 will give you 4. So the base of the triangle is 4, and the height also is 4. So half base by height, half 4 by 4 will give you 8. Now you will add the 60 and 8 to give you the total area of the composite figure, which is 68 square inches. And let's solve a problem. Let's take problem A, for example. I will divide it this way so that it will be a rectangle and a triangle. The area of the rectangle is very easy. I'll name it area 1. And the triangle, I will name it area 2. And after I find them, I will add. So area 1, which is a rectangle, it needs length and width. So 4 times 12. 4 multiplied by 12, this will give you 48 feet. square. Now for this triangle, it needs a base and height. How can we find the base? The base is horizontal line, so get it from the horizontal lines. You have here 12, and you have here 8. So 12 minus 8 will give you here 4. So the base is 4. Also, we need the height of the triangle. The height of the triangle is a vertical line, so get it from the vertical lines. Here we have 10, and here we have 4. So 10 minus 4 will give you here 6. So the area 2, which is an area of a triangle, it's half base by height, means half times 4 times 6. Half by 4 is 2, 2 by 6 is 12, 12 feet squared. So area 1 plus area 2 is 48 plus 12, and 48 plus 12, this will give you 60 feet squared. Now figure B, also I will divide figure B into two well-known figures this way. So it will be two shapes, as you can see. I will name this area as area 1 and this area as area 2. So that area 1 is a square because it has length and width are the same, 7 and 7. So I will find the area 1 now, which is 7 multiplied by 7, that is 49 meter square. Now area 2 is shaped like a trapezoid, and you know that the area of the trapezoid, it needs height and sum of bases. So half the height multiplied by sum of bases. Base 1 is very clear. Base 1 is very clear, is 5, and base 2 is 7. Exactly the same as this one. So this is 5 and this is 7. So here 5 plus 7. And the height is a vertical line, as you can see. So get it from the vertical lines. Take the 10, all of it minus 7. So 10 minus 7 will give you here 3. So the height is 3. So this is like half multiplied by 3 multiplied by 5 plus 7, which is 12. 3 by 12 is 36, and half of 36 is 18 meters squared. So the area of figure B is like 49 plus 18, and this will give you 67 feet. Sorry, not feet. It's meter, so meter squared. This example, it was at the beginning of the book, and we want to find its area now. So we divide it into a rectangle, as you can see. And this part outside the rectangle, it's a trapezoid. So the area of the rectangle is very clear. It's length times width, which is 14 multiplied by 28. This will give you 392. Now we want to find the area of this trapezoid. It's half height multiplied by base 1 plus base 2. The height here is 2. This is base 1, which is 4. Base 2 is 6. The trapezoid is flipped, as you can see. So this is the height, which is 2. The line between the two bases. And base 1 is 4. Base 2 is 6. So half F2 is 1, 4 and 6, 10. 1 by 10 is already 10. So now we are going to add the rectangle plus the trapezoid. 392 plus 10 will give you 402. Now we need to find out the area of this figure. So we will divide it into two figures. I will divide it this way. to be a rectangle and a trapezoid. I'll name this area as area 1 and this area as area 2. I'll try to find the area 1 right now, which is length times width 14 multiplied by 36. And 14 multiplied by 36 will give you 504. Of course, feet squared. Now I want to find the area 2. Area 2 is shaped like a trapezoid. The trapezoid, it needs a half multiplied by the height multiplied by sum of bases. Sum of bases is very clear. Base 1 is 20. Base 2 is 36, exactly like this one. Horizontal line, exactly like this one. So 20 plus 36. Now the height. The height is this part. Let me highlight it for you. It's in blue now. This part. This part is a part of 20 because 20 is the whole dotted line. From the top to the bottom is 20. So it's a vertical line. We get it from vertical line. So 20 minus 14. 20, all 20 minus 14 will give you 6. So the height is 6. This 10 is extra information, or for someone maybe divided this way, but I divided this way. So forget about the 10 for now, because we didn't divide the figure vertically, we divided the figure horizontally. So now, what is half of 6? Half of 6 is 3. 20 plus 36 is 56. 3 times 56 will give you 168 feet squared. Now the whole area is like 504 plus 168, and 504 plus 168, this will give you 672 feet squared. Overlapping figures are two figures that they have intersection part. So this is figure number 1. As you can see, it's a square because it's 12 and 12. And I have here figure number 2. It's a rectangle because it's 12 by 15. And they have this common part. This common part inside. This common part, we will subtract from the two figures. Means we will evaluate the area of the first figure and we will evaluate the area of the second figure. And because this part is a common part, it has evaluated twice, one time in the original figure and one time in the other figure. So we will subtract it one time. So the whole idea is about what? Area of figure 1, area of figure 1 plus area of figure 2 minus the overlapping part. Area of figure 1 plus area of figure 2 minus the overlapping part. This is what they did right now, as you can see. They evaluated the area of the first figure, which is a square, 12 by 12, 144. They also evaluated the area of the second figure, which is a rectangle, 15 times 12, or 180. And we find the sum of them, as you can see. We find the sum of them, 324. Now we evaluate the overlapping part, 7 by 6. How do we know that this is 7 and this is 6? Very easy. If it's a vertical line, get it from the vertical lines. You have here 12 and 6. This is 12 and this is 6, so this one for sure is 6, the rest of 12. And here, the horizontal part, to get it from the horizontal part, this is 15 and 7. So 15 minus, 15 and 8. 15 minus 8 will give you here 7. So this is 6 by 7. 6 by 7 is 42. Now, we will subtract 42 minus 324 minus 42 will give you the area over the overlapping part. So consider it as a rule, area of figure 1 plus area of figure 2 minus the overlapping part. Let's take an example to make everything clear. I'll find now the area of the first figure. This figure, for me, it's a rectangle 6 by 8. So let's say area 1 equals 6 multiplied by 8, which is 48 feet squared. Now let's find the area 2 of the second figure. This is the second figure. It's very clear that it's 7 by 6. So 7 multiplied by 6, this will give you 42 also feet squared. I'm going to add them now, the same style of the book. So area 1 plus area 2 equals 48 plus 42, that is 90 feet squared. Now let's evaluate the overlapping part. Let's name it area 3. The overlapping part, let me highlight it for you. This part, Shabab, the overlapping part. Of course, we need to find its dimensions. So, as I told you, vertical line from vertical lines. Look at the 7 and 2. This 7 minus 2 will give you this one as 5. Let me choose another color. This one will be 5. And the horizontal will come from the horizontal. This is 6 and this is 1. So 6 minus 1 will give you another 5. So area 3 is 5 multiplied by 5. This will give you 25. Now, our area is 90 minus 25. And this will give you 65 feet squared. So, overlapping, area of the first figure, area of second figure, minus the overlapping part. That's it. Moving on. Problem number 1. The manager of an apartment complex will install new carpeting in a studio apartment. The floor plan is shown at the right. What is the total area that needs to be carpeted? So I will divide it this way to make a rectangle and trapezoid. I'll find the area 1. So area 1 equals length times width, 10 multiplied by 25, which is 250 feet squared. Now I'll find the area 2, which is a trapezoid, and you know that in area 2 trapezoid, it's half the height times sum of bases. Bases are very clear, which are 12 and 25, 12 plus 25, because for sure this line is the same as this line. The height is very clear here. This is the height, that is the perpendicular between the two bases, which is 5. So the height here is 5. Now, we should find half times 5, which is 2.5, and 2.5 multiplied by 12 plus 25. 12 plus 25 is 37. And 2.5 multiplied by 37, it is 92.5 feet squared. So finally, the total area is 250 plus 92.5, and this will give you 342.5 feet squared. Now for this problem, the overlapping part, let's find the area of the first figure, this one. Let's say area 1 equals, it's a rectangle, so 28 multiplied by 30. And 28 multiplied by 30, this gives you 840, of course, feet squared. Now let's find the area of the other figure, which is a rectangle as well. Let's say area 2. Its length times width, so 33 multiplied by 42. And 33 multiplied by 42 should give you 1,386. Now we will follow the style of the book and we are going to add them. So area 1 plus area 2 will be 840 plus 1,386. And this should give you 2,226 feet squared. Now we need to evaluate the overlapping part, and let me highlight it for you. This overlapping part, we need to find its dimension, to find its area, the locker room. So I told you before, horizontal line, bring it from horizontal line. So 28 minus 14 will give you here 14. Because this one, all of it is 28 like this one. This one, all of it, it's 30 like this one. So 30 minus 16 will give you also 14. So 14 multiplied by 14. So area 3, the overlapping part, is 14 multiplied by 14. And 14 multiplied by 14 will give you 196 feet squared. Now, finally, the total area will be the sum of the two figures, 2,226, minus the overlapping part, 196. And this will give you 2,030 feet squared. That's it for our lesson for today. And if you have a question, write it down in comments.